Episode 34, titled WAN Selection Framework, MPLS, SD-WAN, DIA, Metro, Dark Fiber, we frame wide area network choice as matching connectivity to business outcomes, because the best link is the one that meets the organization's reliability, performance, and governance goals without creating hidden operational risk. The exam likes this topic because it mixes technology with constraints, and it rewards the candidate who can choose based on latency sensitivity, redundancy needs, cost discipline, and control expectations rather than on brand reputation. Wide area network decisions shape user experience, security posture, and incident blast radius, and they often outlive individual applications because circuits and contracts persist for years. A good framework starts with what must not break, such as voice quality, transaction timeouts, or regulatory boundaries, and then chooses the connectivity model that supports those outcomes predictably. This episode builds that framework by comparing common options and linking each to the kinds of scenarios where it is most likely to be the best answer. The goal is to make your selection logic consistent so you can justify it under exam pressure and apply it in real planning conversations. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Multi-protocol label switching, commonly shortened to MPLS, is often chosen for predictable performance and provider-managed routing because it gives organizations a private wide area network with defined behavior and a single provider responsible for the transport. Predictability matters because many business applications depend on stable latency and low loss, and MPLS networks are designed to provide consistent routing and service levels across a provider backbone. Provider-managed routing matters because it reduces the need for enterprises to manage complex intersite routing themselves, and it can simplify troubleshooting by making the provider accountable for core reachability between sites. MPLS is also often associated with quality of service support, which can help prioritize voice and critical traffic when link contention occurs, though the operational value depends on the end-to-end design. The trade-off is cost and flexibility, because MPLS circuits and bandwidth can be expensive and can have longer provisioning lead times than internet-based options. In exam scenarios, MPLS often fits when the prompt emphasizes stable performance, regulated traffic handling, and a desire for provider-managed transport rather than do-it-yourself internet routing. The key is that MPLS is an engineered private transport choice, not simply a more secure internet. Software-defined wide area network, commonly shortened to SD-WAN, is typically chosen for dynamic path selection and centralized policy because it treats the wide area network as a set of available paths and then makes intelligent decisions about which path to use for each flow. Dynamic path selection is valuable when branches have multiple links, such as a mix of broadband, cellular, or dedicated circuits, and the goal is to use the best available link at any moment based on latency, loss, and jitter conditions. Centralized policy is valuable because it allows consistent rules across many sites, such as steering critical application traffic over the best path, sending bulk traffic over cheaper links, or enforcing consistent security controls through defined gateways. SD-WAN can also enable direct breakout to cloud services or to the internet while maintaining policy consistency, which can improve user experience by reducing hairpin routing through a central data center. The trade-off is complexity and dependency on the SD-WAN control plane because policy, monitoring, and security integration must be managed well to avoid unpredictable behavior. In exam scenarios, SD-WAN often fits when the prompt includes multiple links, variable internet performance, and a need for centralized control and optimization across many sites. The key is that SD-WAN is an overlay and policy framework that can improve experience when the underlying links are inconsistent, but it still depends on having at least two viable paths to choose from. Dedicated Internet Access, commonly shortened to DIA, is attractive for simplicity and cost, especially when direct internet breakout aligns with application usage patterns and when the organization can tolerate variability. Dedicated internet circuits provide direct access to the internet, which is increasingly relevant because many business applications are cloud-hosted and do not need to traverse a private enterprise backbone to be useful. DIA can reduce backhaul latency because branches can reach cloud services directly rather than hairpinning through a central site, improving user experience in software-as-a-service heavy environments. Cost is often lower than private circuits, and provisioning can be simpler, making DIA an appealing choice for many branch sites. The trade-off is that internet performance can vary, and security and policy enforcement must be designed deliberately because the branch is now closer to the public internet and may need consistent inspection and identity controls. In exam scenarios, DIA fits when the prompt emphasizes cloud access, cost discipline, and direct breakout, and when the organization can manage security at the edge or through centralized policy solutions. The key is that DIA works best when you embrace Internet-first architecture and design security and resilience accordingly, rather than pretending it is a private circuit. Metro networks and dark fiber are often chosen for high-bandwidth local connectivity, particularly when locations are close together and when the organization needs predictable, high-capacity transport for data center interconnect or campus-style networking across a city. Metro connectivity can provide strong bandwidth and relatively consistent latency within a metropolitan area, making it suitable for linking data centers, connecting large offices, or supporting high-volume replication. Dark fiber is the most control-heavy option because the organization effectively leases fiber and then controls the optics and transport, which can provide very high bandwidth and low latency, but it also increases operational responsibility. These options are less about branch internet access and more about building a high-capacity local backbone where application performance and replication volume justify the investment. The trade-off is operational complexity and sometimes higher initial cost because managing optical transport and redundancy planning becomes the enterprise's responsibility rather than the provider's. In exam scenarios, Metro and dark fiber appear when the prompt mentions two data centers in the same city, large replication traffic, or need extremely high bandwidth with low latency. The key is that these are locality-based, high-capacity solutions, and they are usually justified by heavy internal traffic and tight performance constraints rather than by general internet access needs. A solid selection rule is to choose based on latency sensitivity, redundancy, cost, and control, because these four factors capture most business constraints. Latency sensitivity asks whether voice, real-time systems, or transactional workloads demand stable delay and low jitter, which pushes you toward engineered paths or multi-path optimization rather than best effort internet alone. Redundancy asks whether the business can tolerate link failure and how quickly it must recover, which pushes you toward dual-path designs and possibly SD-WAN when multiple links exist. Cost asks whether the organization can sustain premium circuits across many sites and whether bandwidth needs justify those costs, which often drives hybrid designs where critical sites get higher assurance links and smaller sites get cost-effective internet with backup. Control asks who must manage routing, policy, and security, and whether the organization prefers provider-managed simplicity or enterprise-managed flexibility and visibility. In exam scenarios, these factors are often embedded as constraints like must reduce costs, must ensure stable voice quality, limited staff, or must meet compliance, and your answer should map directly back to those constraints. The best answer is the one that explicitly satisfies the dominant factors rather than optimizing one and ignoring the others. Consider a scenario where SD-WAN improves branch experience with multiple links, such as a branch that has both broadband and cellular, and users complain about inconsistent voice quality and slow access to cloud services during peak times. In this case, dynamic path selection can route latency-sensitive flows over the best-performing link at the moment, while sending bulk traffic over a cheaper or less consistent path. Centralized policy ensures the same steering rules apply across the branch fleet, reducing configuration drift and making troubleshooting easier because policy intent is consistent. SD-WAN can also support local internet breakout for software as a service while maintaining security controls, reducing hairpin latency, and improving user experience. The design becomes more resilient, because if one link degrades or fails, traffic can shift to the alternate path with minimal downtime, aligning with availability expectations. In exam reasoning, the presence of multiple links and variable performance is a strong cue that SD-WAN adds value, because it can convert link diversity into better experience and reliability. The key is that SD-WAN is most compelling when you actually have path choices and when policy can meaningfully steer traffic by application needs. Now consider a scenario where MPLS fits regulated traffic needing stable paths, such as a set of sites that handle sensitive transactions and must meet strict service levels with predictable latency and clear provider accountability. In such a case, a provider-managed private network can provide consistent routing and performance characteristics, which can be easier to validate and easier to govern than best-effort internet paths. The organization may also value having a single provider responsible for the core transport, reducing the operational burden on internal teams and simplifying incident escalation. MPLS can support prioritization of critical traffic, and in a regulated environment, the predictability and contractual service levels can align well with governance and audit expectations. The trade-off is cost, but if the business impact of instability is high, the premium may be justified for those sites or those traffic classes. In exam scenarios, cues like compliance pressure, high cost of downtime, and need for predictable performance often push toward MPLS or a similarly engineered solution rather than pure internet. The key is that the protocol is less important than the outcome. Stable, accountable, and predictable connectivity for critical flows. One pitfall is assuming internet links provide consistent latency always, because internet performance varies by time, congestion, and path selection, and that variability can break real-time applications. Broadband circuits can have good average performance but poor worst-case behavior, and it is the worst case that often drives user complaints and transaction timeouts. Even dedicated internet access circuits can experience variability because the broader internet path to a given cloud service can change, and upstream congestion can introduce jitter and loss. This is why designing for real-time quality on internet-only transport often requires either multiple paths with intelligent selection or acceptance that some degradation will occur. In exam questions, if the scenario demands consistent latency and jitter control, answers that assume internet is fine are usually traps unless additional controls and redundancy are included. The best answer acknowledges variability and proposes either engineered transport or multipath strategies that mitigate it. The practical lesson is to design for the tail, not for the average, when user experience depends on stability. Another pitfall is ignoring provider lead times and contract constraints, because circuit provisioning and contract terms can delay projects and force temporary architectures that become permanent. MPLS and metro circuits can have longer lead times than Internet circuits, and dark fiber may involve significant planning, permitting, and coordination. Contract terms can also lock in bandwidth levels and pricing for long periods, making it hard to adapt if application needs change or if sites are relocated. If a design assumes a circuit will exist soon, but the lead time is months, the organization may deploy a stopgap that becomes production, often with weaker security and less predictable performance than intended. Exam scenarios sometimes hint at timeline constraints or new branch opening soon, and in those cases, the best answer often includes a realistic approach that accounts for provisioning lead times. The key is that feasibility includes procurement reality, not only technical correctness, and the exam can reward you for recognizing that. A strong design anticipates lead times and includes phased plans that do not compromise security or reliability during transition periods. There are quick wins that improve nearly any wide area design, such as designing for dual paths and testing failover regularly, because resilience is only real when it is exercised. Dual paths can be two different providers, two different media types, or two different physical routes, and the point is to avoid a single failure that isolates a site. Testing failover ensures that routing, policy, and security controls behave as expected when one path degrades, because untested failover often fails at the moment you need it most. This is especially important in SD-WAN designs, where policy complexity can create surprising behavior under failure conditions. Dual paths also help in Internet-based designs, because variability can be mitigated when there is an alternate route with different congestion characteristics. In exam scenarios, when availability and continuity are emphasized, answers that include dual-path design and regular validation tend to align with best practice. The key is that wide-area networks fail in the real world, and resilient designs assume that reality rather than hoping for perfect uptime. A memory anchor that keeps the framework simple is performance, policy, price, and provider constraints, because these four categories capture most selection decisions. Performance includes latency, jitter, loss, and bandwidth, and it determines whether engineered paths or multipath optimization are needed. Policy includes the need for centralized control, security enforcement, and traffic steering, which can favor SD-WAN when many sites need consistent behavior. Price includes both recurring costs and scaling costs, especially when many branches are involved, and it often drives hybrid approaches rather than uniform premium connectivity everywhere. Provider constraints include lead times, contract terms, availability of services in a region, and operational support models, which affect feasibility and long-term flexibility. When you recite these four factors, you can justify a selection in plain language that maps directly back to scenario constraints. The exam rewards that justification because it demonstrates disciplined decision-making rather than brand preference. This anchor also helps you compare options quickly without getting lost in features. To end the core, choose a wide-area approach for 3 branches with different needs, because that exercise forces you to apply the framework rather than memorizing definitions. Imagine one branch is a small sales office using mostly software as a service with moderate tolerance for occasional jitter. Another branch is a call center with strict voice quality requirements. And the third is a regulated processing site with strict compliance and high downtime cost. The sales office might fit dedicated internet access with a backup path because cost and simplicity matter and the workload is cloud-heavy. The call center might fit SD-WAN with 2 diverse links because dynamic path selection can protect voice quality by steering real-time flows to the best path and failing over quickly. The regulated site might justify MPLS or another engineered private transport, potentially augmented with backup internet because predictable performance and clear provider accountability align with compliance and continuity requirements. The key is that you do not force one solution across all sites. You match connectivity to the impact of failure and the nature of the traffic. In exam reasoning, this kind of differentiated selection is often the best answer because it reflects realistic business constraints and avoids overpaying where it is unnecessary. In the conclusion of episode 34, titled WAN Selection Framework, MPLS, SD-WAN, DIA, Metro, Dark Fiber, the selection logic is to match wide area transport to business outcomes using performance needs, policy requirements, price constraints, and provider realities. Multi-protocol label switching offers predictable performance and provider-managed routing. Software-defined wide area networking offers dynamic path selection and centralized policy across multiple links. And dedicated internet access offers simplicity and cost advantages with direct breakout when cloud usage dominates. Metro networks and dark fiber are high-bandwidth local connectivity options suited to nearby sites and data center interconnect use cases where control and capacity justify the operational IOC. You avoid pitfalls like assuming internet latency is always consistent and ignoring provisioning lead times and contracts that can derail timelines. You gain quick wins by designing for dual paths and regularly testing failover so resilience is proven rather than assumed. Assign yourself one WAN comparison rehearsal by taking a single site and stating its latency sensitivity, redundancy requirement, cost tolerance, and provider constraints, then defending one option and one alternative, because that structured justification is what the exam is measuring. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.